This is section 913. We're going to take a look at sum and difference identities. So we're going to use the sum and difference identities to evaluate the trig value. So just as a reference, these are our identities. They need to be memorized. So let's find the cosine of alpha plus beta. Now, with this information, what it's saying is that I have two rotations. I have an alpha rotation, an angle, and then I have a beta rotation. So I can draw those real quick. So here's my alpha rotations between 0 and pi halves, so that's in quadrant 1. And then it says I have my beta rotation. We'll say that that's beta. And that's in quadrant 2. So there's my rotation in quadrant 2. So rotates, rotates. Now it gives me information about it. It gives me a ratio. So cosecant, this is 3. So if I think of that as 3 over 1, SOHCAHTOA, that's sine. So if I said the sine of alpha, that's going to be 1 over 3. So that's going to be opposite over hypotenuse. And then this would be, 2 root 2, because a squared plus b squared equals c squared. X squared, 9 minus 1 is 8, so square root both sides. X equals 2 root 2, if you had to reduce 8. So that means with this triangle, I can say the sine of alpha is opposite over hypotenuse. The cosine of alpha is adjacent over hypotenuse. Now my other quadrant says tangent, -7. So if I think of that over 1, so it's opposite over adjacent. So opposite over adjacent. Now the 1 is moving in the negative direction, so that gets the negative. Now I know you might be thinking, well, it says -7. Why doesn't 7 have it? Well, it's moving up. My y is positive. So it has to go with the x because it's moving in the negative direction. And so again, I can do my SOHCAHTOA, my Pythagorean. So a squared plus b squared equals c squared. So this is 49, this is 1. So that's 50, square root. So that'd be 5 root 2. So now, if I wanted to find my sine alpha, that's going to be opposite over hypotenuse. And my cosine, this is beta. And if I wanted to find my cosine beta, that's going to be adjacent over hypotenuse. Now, just to rewind, it's like, why did I do all this? Well, it's asking me to find cosine of alpha plus beta. If I just started with cosine of alpha plus beta, using the identity, that's cosine alpha, cosine beta, minus sine alpha, sine beta. So what is my cosine alpha? I just found it. So this becomes 2 root 2 over 3. What is my cosine beta? I just found it. That becomes -1 over 5 root 2. What is my sine alpha? That's going to be 1/3. And then my sine beta is 7 over 5 root 2. So multiplying the tops, I get -2 root 2 minus, multiplying the tops, -1 times 7 over, now the bottoms, you get 15 root 2. Now I know there's a radical in the denominator. Yeah, you can rationalize it, but this is good enough. We can get to this point, we're good. Let's look at another one. So sine alpha wants me to find tangent of alpha plus beta. So the tangent of alpha plus beta, I know that identity is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So I need to find tangent alpha and tangent beta to be able to plug it in. So here's my triangle for my alpha. That's going to be in quadrant 1. So sine is opposite over hypotenuse. using SOHCAHTOA, I know that this is going to be 4. So tangent is opposite over adjacent. Now I have to do the same thing for beta. Now between 3 pi halves and 2 pi, 0, pi halves, pi, 3 pi halves, 2 pi. Okay, so between 3 pi halves and 2 pi, that's going to be quadrant 4. And so that's going to be cosine, so that's adjacent over hypotenuse. This will be -5. It's negative, it's going down. And so my tangent is going to be opposite over adjacent. So now I plug everything in. Tangent alpha is 3 over 4 plus tangent beta all over 1 minus tangent alpha, tangent beta. Find the common denominator. So that's 9 minus 5, so that's going to be 4 over 12. I'm going to leave that 12 because you're going to see why in a second. And then here, I'm going to have to multiply those, so that's going to be 48. So I'm just going to do the denominator here. 1 minus negative, and a negative is a positive, so plus 15 over, and that's going to be 48. So the common denominator is 48 over 48. So 14 plus 48 plus 15, that's 63. And that's going to be over 48. So now this 12 and this 48 will reduce. That's the reason why I left it alone, because it would reduce. And then that's going to be 4. And so this becomes a 1. And so as the shortcut, these two multiply, and so you're going to get 16 over 63. So what did we learn today? We continued using our sum and difference identities, and this time we applied it with trig ratios and evaluated using those trig ratios. This does conclude our lesson. If you have any other questions, please leave them in the comments.